this will go. Oh, that's bright. Oh, that's even brighter. Oh, man. So I've been scaling the sensor, the laser height sensor, and as you can see, I'll show you now when I'll turn the camera around. Wait. As you can see, now it says 224 millimeters. That's down to this cardboard box, and that's about where the ground is. And lifting it up, it will the more closer to the sensor, the less voltage, and it says near when it comes too close, but this will never happen because it's dragging the pipes in that case. And now I'll go down to the floor, let the sensor read the floor. I'll take this away, the floor underneath the dyno. It says 651 millimeter, but now the sensor is scaled. I haven't scaled it completely yet. You can see the value right here. I'll take a screwdriver and show you. This is the value, 5 volts. It maximizes out the input on the Maxxecu. But this is a wheelie that is about, from the sensor to the ground, 630 millimeter about. It's only 20 millimeters from the floor. It's becoming over 5 volts from the sensor. Maxxecu is maxing out at 5 volt, but I can raise the level. I have set the sensor now at the sensor maximizes out at 10 volt at 1200 millimeters, setting it so the sensor maximizes out at say 1200, no, 13, 14, 1500 millimeters. I would have more control even higher, but probably isn't necessary. But I'll have to test that on the street though. As it is of now, the system works really good. And now I need to build in Maxxecu a timing curve that compensates, that starts compensating to the voltage it reads. So say in this case it sends out now when it sits, wait, that cardboard box again, and now it sends out 1.8 voltage something. It's flimmering a little bit, jerking around a little bit, a tenth of a volt, nothing to worry about. I can't put a filter inside the sensor, I read, so it smoothed out the values a little bit. But I think I can also make the same in Maxxecu, not read those small numbers. So let's say at this point where it sends out 1.8 volt ride height, no correction to the timing curve. And then as the front wheel, I'm about to allow 10 centimeters of a wheelie, maximum, probably 8 to 12 centimeters, so I'll pick 10 centimeters maximum, 100 millimeters. That's maximum. Above that it will almost cut the ignition. But from that, let's say 80 millimeters no reaction, 100 millimeters a little bit of a reaction on ignition, and 120 millimeters, let's double that reaction, and then let's say 140, 150 millimeters, let's just go insane with retard. That would probably retard so much, maybe it starts to puffing and banging in the exhaust. And this is a thing I need to tune later on the street or on the track. Now in the dyno I can't tune it. This is a thing I need to test drive. But I can dyno it. Let's say I pull 10 degrees of timing at 100 millimeters lift. I can dyno with 10 degrees less ignition input and see what the power level is. It probably almost kills the engine. So I'll start building a timing curve and let you come along with that. I'll pause now and set up the camera. So this is the Maxxecu acceleration input compensation table, and I actually I can use this table. I do not need to alter it. Earlier I had a G-force sensor in Z-axis up and down on the bike. It's a little bit of a jerky signal, so I didn't get any good data to compensate from with that. This is now, you can see I can't reach the bike right now. I can go show you soon, but as you can see right here, this is bike in the resting ride height position, and the more bike rises, the further up this will go, and the more speed the bike has. So I can compensate from height and speed. That's quite good. So let's say at it's very prone to go on the rear wheel at say underneath 60 kilometers an hour. I can put compensation concentrated around here and upwards, and then I can just make it fall out above, so it isn't there and disturbing the function of the bike. So I'll tap the camera a little bit. So I can now, I'll go away from the screen a little bit and we'll just wait 10-15 seconds after I'm getting quiet almost. You will see this cursor move. It will sit bam on top because it will read the floor and the voltage is getting too high. I think it's going to the top, we can see. Yeah. Now it's reading the floor, and it's I can scale it a little bit more. This is wait, I'll check. This is 652 millimeters from the sensor, and well, having that big wheelie, let's say it's about 400 millimeter high wheelie underneath the engine is way too much anyway. So this scaling is working. I can just, when it reaches maximum, I can just retard ignition like 50 degrees. No, not 50. Let's say I'll retard it 25 degrees. It just kills the engine. So if it reaches this high, engine won't pull at all and it will come down immediately. So this is the function. And I'll start putting in some values though. Let's say up to 60 kilometers an hour. I put, when it starts lifting the wheel, I don't know where 10 centimeters is now. I'm just guessing. Let's say it's about here. And I'll put in a value. I'll retard 5 degrees. So now I got 5 degree retard in this area, and then I can set right up in there, change value. Let's say I'll put in minus 20 degrees, and now I can interpolate vertical. Now you see, then I can of course fine-tune this, but this is a bit not something to begin with. Let's say I'm guessing now, it has risen the front wheel about 100 millimeters from the ground. And a little bit more, it starts to retard the ignition, and the more it rises the front wheel from the ground, it pulls away more and more timing. And above 60.7 kilometers an hour, it stops. It just lets the engine eat. It gives it full power. So that's the function of it. Quite interesting to test this. So I'll put back the cardboard box so it will read, and I'll show you when I put it back. I'll lift it a little bit closer to the engine. It will go down to the lowest point right here. First it sits second or third, I can't remember, and then it goes down when I'm lifting it, getting closer. Now we're back. I can raise my voice so you can hear. Now I'm lifting. You can see, there it is, max, and it's about 5 centimeters. Maybe a little bit less, I don't know, more. And in that direction I won't do anything, because this is ride height. A little bit sitting on the bike, it sags down a little bit, but not that much. It sags down just a couple of centimeters maximum. So this will get a little bit lower, and then I got all this to have fun with. Enough of that. I thought I'd go out, take a test drive also on this one, the Overkill bike. And I have bought new gearing. I have -2 cogs on that one and plus 15 on that one. And that'll be interesting. So let's go. Yeah, it goes like stink. But it's disgusting to run. I forgot to fill air in the tires. They're just wobbling. So yeah, another day, another time. But I think it's working quite good now. I had to weld though at the, oh, it's leaking oil again. This one's, I need to do something. I need to weld this ones. Anyway, yeah, I cut it off right here and go home. So I've been out there trying it for a run. This hardcore, what is it there, machine. But I got the same problem once again. It's leaking oil from the balance shaft. The millimeter 5 bolts seems to be too small for that. I need to do something, either double the amount of them, or it's hard to put larger in. I can show you anyway. Firstly because it leaked oil and the gearbox will be out of oil, but secondly this oil, as you can see, a puddle over there, it's also, the tire is wet also on the sides. So, and I also forget, I got slow air leak on both rear and front tires, so I forgot to fill those up before I was taking the test run. So it was a little bit wobbly. Well, not wobbly, it's like kind of like worm, but I got some good gear shifting. Yeah, and we'll see you in the next time, guys. Bye.